Surely there's a Harry Potter after this.
All right.
Sure.
Question. Go ahead.
Can we see 2.71 works with evidence?
Sure. Absolutely. This is Thevenin, right?
The problem statement doesn't ask for it, but 2.77 says where 2.71 is evidence.
All right. Okay, let me get to there. So you want from 2.71?
That's right.
All right. Now, it says source transforms. If I have time, I'll show you that today. I don't have, you remember, you can get this answer a lot of different ways. You don't need to use source transforms. Do you have a way you want to do it?
Yeah, 2.77 says solve 2.71 with evidence.
Okay,
So,
good.
Yeah.
Yeah, evidence is fine. Let me try to draw this. Actually, this is problem, the template is 2.71, and it looks like this. It's actually 12 volts. This is 3K. 3K. All right, is that right, class? Is this 6K?
Yeah.
Thank you. And let me go ahead and just make this a little nicer. So this is plus to minus 12 volts, correct? Y'all see this? We're going to use Thevenin's on this one. All right, now again, Thevenin's, in my opinion, is the most useful because it usually makes everything easier. Not always, but usually. So the first thing Thevenin says, or if you're applying Thevenin's theorem, is find the load. So what is the load resistor, class?
3K.
Everybody see it's 3K. It's the element, can you get that? Element we want, the unknown voltage or current value. Correct, class? So it's 3K. And then what do we do with it? Remove it, right? Everybody with me?
Yeah.
So remove it. Here's how I'm going to remove it. Okay? Next part, I want everybody to listen. Make sure you see this. There's nothing hard about this. Just be attentive. And think of current like fluid or water. Think of voltage like pressure. Resistance like the diameter of pipe, in a sense. The bigger the diameter, the less resistance. You make sense with that? All right. Follow me on this one. Now, this is an open circuit. No current can flow in or out of those terminals. Do y'all follow me? Think of it as a capped pipe. Nothing can flow in or out. With me? Come here just for a second. Y'all see that this 4 milliamps must go that way. Y'all see it? How many do? If you do, you know that is the current flowing, period, right? If you know that current flowing, so I got a different colored marker. Then you all see that the voltage across this 6K will be that current times 6K, and the voltage will be plus to minus, right? It will be 4 milliamps times 6K, K and milli cancel, or I get 24 volts here. You all see that, class? Give me a show of hands. How many see it? I took the current that must flow through there, right? And I multiply it by the resistance that exists there to get the plus to minus voltage. Positive current enters the positive terminal of a voltage defined as I times R. Correct, everyone? All right, now, how much current flows here? How many say it's 0? Nothing can flow. What's the voltage across that resistor? 0 because of that. So there's 0 volts, doesn't, you don't even have to put it there, right? Now, what it asks for is the voltage V out. I mean, V open circuit. It actually, second thing I'm going to find is V open circuit, which happens to be what that is, isn't it, class? I remove the element, the resistor. Now I want to find the voltage that exists across that opening, you might say, correct? I always start at the negative terminal, and I go to the positive, and I find out the value. So I go from here to here is a decrease of 12, minus 12, correct, class? Go here, this is a decrease, correct, class, of 12, so it's minus 24 when we're out here, correct, class? Minus 24 plus 24 is 0. 0. Y'all see that, class? It's
Why is it 2
this, oh, I'm sorry. Minus 24. Minus 24 minus 24 is minus 48. I am so sorry. I thought he was going to give you one that worked out to 0. My bad. So it's minus 12 is minus 24. It goes from plus to a minus, another 20, minus 48 volts. How many see that? I'm so sorry. And then this is 0, so it's minus 48 volts. Okay. Third thing is what? We find R Thevenin, right? Now, how do we find R Thevenin? Remember, people? I turn off the sources, right? And I look at the resistance that would exist between the terminals where I remove the actual element, right? The load. How many remember that? All right, so I turn off the sources. What does a current source become when I turn it off? Open circuit, right? Nothing can flow, right? It's like cutting it out. How many remember that? Right? It's an open circuit. That's a current source. So just erase it. What does a voltage source become, class?
Short circuit.
Short circuit. Turn off, V goes to 0, the battery's short. Think of it that. So I'm just going to make them a short circuit so you can see. Y'all agree with that? Now we want the resistance that exists between these terminals looking back at the circuit. Y'all see it's going to be 3K and 6K in series? Give me a show of hands if you can see that. That is 9K, correct? Now, after you've done that, the final step is you assemble the Thevenin equivalent circuit for everything on that side. So I put the open circuit voltage. Here it's plus to minus 48 volts, right? But it's a minus 48, correct, class? You notice how I've gone ahead, I know the plus is on top, the minus is on the bottom, because that's the way we've done our business here, right? And it's minus 48. Now, I'm going to reverse those terminals in a second, but for now, leave it as minus 48, because that was the value. Do you all follow me on that, class? Now, the next thing you do is you put the Thevenin equivalent resistance in series. That's 9K. Now, I want to tell you this. It doesn't matter what load you plug in here. It doesn't matter if it's the original or any other load, you'll get the right value of current that would flow. Do y'all follow me? We've reduced the complexity of the circuit down to a resistance and a voltage, and no matter what we plug into it, it will give you the right value of current that would exist after we plugged it into the original circuit. Do y'all follow me? That's the power of this thing. Now I don't care how many different things I want to plug in here, I'll know what the current voltage is and technically the power. Now the last step is I put back my original resistance, and that was 3K, right? By the way, they want the voltage, don't they? All right, so really they want this voltage. Now I'm going to tell you this much. You can leave it as minus 48 if you want. And you can say this voltage right here will be V voltage. Notice it's plus to minus, right? Minus 48 times the resistance you want the voltage across, or 3K, divided by the sum of the two. Do y'all follow me? We'll do it that way first. So I can say that V out would be equal to the minus 48 times the resistance, 3K. That's the resistance I want the voltage across over the sum of the two, which is 3 plus 9K. And really what I see here, it's minus 48, right? 3 over 12 or 1 over 4, right? Or it's minus 12 volts, isn't it, class? Y'all follow me? How many see that? Who asked this question, by the way? This is a good one. I mean, because it makes you work with that negative value if you want to, right? Let me finish my thought on this one. Now, I could also do this. Well, maybe you have a question before I move on. Go ahead.
Did you say that for the negative 48 volts for the voltage source on the new current, is it plus and minus because
On the Thevenin equivalent circuit?
Yes.
Remember, with Thevenin's voltage, we always find the voltage that would occur here plus the minus. That was predefined, right?
So if that one had been minus and plus.
Then yeah, but again, it's always the Thevenin equivalent voltage. This is a good point. In the element, there's something that designates polarity. In our case, it was pre-designated, plus the minus. That means your voltage has this same polarity, this same sense. Plus on top, negative on the bottom. Y'all follow me? Okay, now, we could also change the polarity. I mean, we could make it a positive value. Just follow me. I could go ahead and say this is really negative to positive plus 48, right? Y'all with me on that, class? And then, I'll get the actual voltage since I don't care about this now. If that's causing current to flow that way, right? Y'all with me? It goes from the positive to the negative terminal, correct? That means this, in reality, this would be minus to plus that voltage 48 over or times 3K over 3K plus 9K or 12K, right? Or really just 1/4 of 48 or plus to minus 12 volts, right? You're gonna see it's the same thing I just did. And in fact, if I wanted the plus to minus voltage here, that would actually be minus 12, right? Because you see how the polarities are. Y'all with me, class? Y'all see, how many see this right now? You good on that? In the far back, can you guys actually see it back there? Wish I had your eyes. I can't when I'm back. Okay. Another question. Yeah.
You do 2.46.
Yeah.
Can you solve it using nodal analysis?
Huh?
Can you solve it using nodal?
Which one?
2.46.
Sure. Anyone you want. Oh. I think we did this one just by combining resistors, right? And then using current division, correct? Well, I mean, we did that. It's a very simple problem. We're going to, you asked for nodal, correct? All right, so for nodal, we ground something, don't we? Do you agree with that? Now, I'm going to make it a little bit simpler if you don't mind. I see that the unknown is the current flowing down here. You all see that? So, are you okay with me adding these two resistors and replacing both with a single value of 12? Y'all with me? Y'all see they're in series, so 12K? So I'm just gonna do this. Y'all with me on that? Yeah. Now, with nodal, one current is defined, actually two currents are defined, or two currents are labeled. Here's what I'm gonna do. I have two unknown voltage nodes, don't I? I have ground here is 0 volts. That's my reference. And here is some V1, and here is some V2. Do you agree with that, everyone? I'm just choose these. It doesn't matter. VA, VB works, anything. Now after that, I have to define the direction of current, don't I? This is my choice, your choice, unless it's predefined. That is already. So I'm gonna call this I1. I'm gonna call this I2. And I'm gonna call this I3. Doesn't matter, could be IA, B, and C if you would like. Doesn't matter the label, as long as it's unique to every current range. You okay with that? Now after that, I use Kirchhoff's current law on node 1, right? And here, everything that flows out flows into. How much is flowing into this node? It's 0. As a matter of fact, just to showcase this node is everything that has voltage V1 on it, right? You see that purple line? Everything that is attached to that has to be V1, right? It's a pressure, electrical pressure. So when we take a look at this, 0 goes in, right? And then all that comes out. So it means I1 plus I0 plus I2 equals 0. Agreed? Now the next thing I'm going to do is replace the currents with the unknown voltages and unknown resistances, okay? Y'all see that? So, if you look at this for I1, what is I1 in terms of the unknown voltages, class? V1 over 12K, you guys are good. What is I0?
V1 over 6.
Right? And what is I2?
V1 minus V2 over.
Thank you. V1 minus V2 over 6K. Do you agree with that? All that equals? 0. Agree? Now the rest is up to you. You know my thoughts on this. I get rid of the K's as fast as I can, right? So I'm going to multiply everything by a K first. And then, this is up to you. I don't like fractions. So I multiply the whole thing by 12. Follow me? You don't have to do it this way, but so this gets a 2 out in front of it, right? And this gets a 2 out in front of it. Agreed? And then I collect terms, don't I? So, what do I get here? I'll put the 0 on this. For V1, what do I get? 2, 4, 5 V1, right? And then minus 2 V2 equals 0. And I do this, and I encourage you to do that. Call that number 1. That's your first equation. Because when you get 4 or 5 of these, now you're not going to, but in the real world, if you don't label these, you can put the same, I should say, a scalar form of the same formula twice, and then you get a solution, you get something that will not solve. Y'all follow me? Or it's overdefined or underdefined, one of the two. Now I come over here to node 2, and what do I get? What flows in to node 2? Y'all see it's going to be I2 for starters, plus what? Plus 12 milliamps, right? Don't forget the units. Y'all see that, class? The 12 milliamps is flowing in here. Do you agree with that? And what flows out? I3. Okay. Next, what is I2? Sure, it's V1 minus V2 divided by 6K plus 12 milliamps, right, equals I3. Go ahead.
V2 over 6K.
right? And again, at this point, it's up to you. This is just me, though. I like to get rid of the K's right off the bat, if I can. This is just me. So I multiply everything by 1,000, right? So I'm down to that, right? Now, at this point, you could multiply everything by 60, right? You agree with that? Because I got a 6 and a 10, right? And again, this is up to you. I don't care. You got any suggestions how you'd like to do this? I mean, if you don't mind fractions, go ahead, put in fractional forms. I mean, then you just separate this thing and you're ready to go, correct? I'm not a fraction guy, so what I'm gonna, let me see, can I make it easier? Oh heck, I'll just do it this way. I'm gonna multiply everything by 60, means this gets a 10, right? This gets a 60, and this gets a 6, right? Y'all agree with me? I'm trying to get rid of fractions. I don't like fractions. All right, now, the next thing I'm gonna do is get this to the other side. Agree with that, class? So that's gonna be minus 12 times 60, right? I could put 720 in there now, but I'm gonna leave it as that so everybody knows where I got it, okay? Then, what do? For V1, I have 10 V1, right? And then I have minus 10 V2 minus 6 V2 is minus 16 V2 is equal to that. And you can simplify this, right? I mean, if you want, what? You could take out, let's see, 2 is 5 and 8 and 6. But I mean, this will work, won't it, class? You agree with that? Got the coefficients, so you can do this. This is only one way. And this is going to be number 2. Now you put it in a matrix, and I got 5, 2, V1, V2 is column vector, and then I have 10 minus 16. Obviously this can be simplified further. For V1 it's 0, for V2 it's minus 720, or 12 times 60. Are you with me? And now you solve it. Now get your, yes sir?
Is the 2 not negative?
I couldn't hear you.
Oh, sorry, is the 2 in the matrix not negative?
Oh, yes it is. Yes, that is my mistake. I'm so sorry. Now normally, I think I mentioned this, I normally circle these because on paper they look like scratch marks to my eyes like that. But I mean, I'm just trying to show you how to do this. Y'all with me? Thank you very much. All right, now go ahead and use your calculator, see what you get. Give me V1 and V2. What?
24.
All right, anybody else get 24? Fantastic. You guys are quick. I'm glad. How about V2?
60.
What?
60.
60. Okay. Anybody else? Confirm?
Yeah, that's what I got.
Okay, you all with me, class? And again, get good with your calculators, be able to punch the numbers and turn the crank, okay? Now, when I take a look at this, the question was I naught. Who asked this, by the way? You two. Okay, now, do you all see that I naught is just V1 over 6K? All right, so I naught here, V1 over 6K, and what is that? 24 over 6K is what? 4 milliamps. I think that's the answer we got when we did current division, right? Y'all see? Now you can do it any way you want, but you can see the current division and just combining things a little quicker, actually. Maybe not. You with me? Yes, sir.
On Wednesday, you set up this problem, but you just had the current at the 6 kilo on the top. You had it going the other direction.
Whoa. You gotta forgive me. On this problem?
Yes.
Can I erase this just hang on. All right, that was it, right? And forget the 0, right? All right, now, how did I know this was going to be 6 milliamps? You remember, class? Anybody? What did I do with these two? Into 4K, right? 12 in parallel with 6 is 4K, right? I have 4K in series with 6 is 10K. 10K in parallel with 10, well, they're two identical things, aren't they? So exactly half the current goes this way and half the current that way, correct, class? Now you asked about this, that's how I got it. And then from that point, when I knew that current, I knew I just used simple current division to find the current there. That's it. Yes, if you guys got questions, don't be afraid to ask. I couldn't understand. What?
I'm good.
All right, now don't be afraid to ask. Everybody, I heard this one time, somebody said, well, don't ask it because, you know, even an idiot's thought to be okay as long as he doesn't say something that identifies him. People would be afraid to ask questions, I promise you, because they think they're stupid. Don't ever worry about that. You're paying for this class, you got a question, you ask it. Don't ever worry about it. Anybody here in the military? Anybody? 1? That's it? 2? 3? I was on the Eisenhower, the USS Eisenhower, right, as a weapons consultant. Did a lot of weapons stuff, radar, electronic weapons. One thing we learned, there's a cardinal rule. There is no dumb question. You know why? It's that one that'll save your life. It'll prevent you from getting your face burned off by a radar or from a bomb going off. Don't ever worry about asking questions. You're paying for this class. Feel you have a right to know, okay? And I mean that, because I know. I have heard people say, oh, well, I could get laughed at. Don't worry about it. I'll deal with them. All right, I'm not going to laugh at you unless you have something stupid about football. I've learned my lesson about football. Man, whew, there is nothing that gets the blood boiling down south worse than the Auburn, Alabama. Heaven forbid I would ever say something positive about the University of Alabama during that week. I would probably be shot straight. And you know, right now it's not that bad with COVID, but I mean, back in the day when Pat died, this is long before you, when I got here with Bo Jackson, my gosh, that was like a holy war. I'm not kidding, it was crazy. All right, anyway, I came from a football college, Penn State, so I'm used to that kind of nonsense, but down here they take it to a different level. All right, now we're gonna have a quiz, so listen to me carefully. I want you to spread out, so here's the deal. Get at least one space between you, one empty seat between you and your neighbor. Fill in the back, move out. It's closed book, closed notes. I want you to take your phones out of your pocket, turn them off and put them face down on the actual desk. I've had people literally trying to look at notes on their phone. I'm not kidding. And I have to flunk them or fire them or something. And would you please just move, if you don't have if you can't find a space, I will provide one, but if you move towards the back, get one space between you and your neighbor. Yes.
Stop recording at this point?
What?
Should I stop recording at this point?